Hi, I'm Mrs. Burns and welcome to Lesson 2 of our Chapter 9 unit on linear relations and graphing them. So we learned last day that a graph is a way to represent the pattern of a relationship between two sets of numbers. So a linear relationship then is a pattern that's made by points that lie in a straight line. So we can graph all sorts of things, but when we have a linear relationship, then the relationship between the value on the y-axis and the x-axis forms a straight line, either up, down, straight across. So let's just recall what the y-axis here was. Here was our y-axis. Across this way is our x-axis. So the y is vertical, x is horizontal, and we need to label them. So let's say this one is money, for example, and this one is time. And if we have a point, say this is 1, 2, 3, -1, -2, -3, because this way down the y-axis is negative, this way up the y-axis is positive, to the right of the x is positive, to the left of the x is negative. So if we have -1, 2, 3 for the y, and say 1, 2, 3 for the x, then if we have a point that is right here, what would that point be in coordinate form? If you were to describe to me where to go to get that dot, what would you say? Well, I hope that you would use the x value first and then the y value. So in this case, our x value is +2 and our y value is -3. So that would be our coordinates for that point there. So we can also make a table of values from a graph, or we could make a graph from a table of values. A table of values is simply a chart that shows us how those two sets of numbers are related. So for example here, this is a table of values. This shows us that there's the time worked here, and then it has the pay earned in money. So notice that we have the hours and the money. So those are the two units here. Now this graph talks about how Benjamin works part-time at a bike shop. He gets paid according to the table of values below. So in 1 hour, he's paid $11. In 2 hours, he's paid $22. 3 hours, he earned $33. And 4 hours, he's earned $44. So let's draw a graph to show this as a linear relation. Well, all we need to do is look for the values here. So on the x-axis here, we have time, and it says already on our x-axis a title, time worked, and it has the units of hours. On the y-axis here we have the pay, and it has here the units of pay is dollars. So you'll notice here that on the bottom that this is 0 and this is 0 at the origin, and that the first box is not labeled, but the second one's labeled 2, and then the next one's not labeled, the next one's labeled 4. So we can see from here that each box is worth 1. So here we go, 1, 2, 3, 4, 5. Or even we could go to the end, 6. So we have each box along the x-axis is worth 1 value. Now we also see that going up the y-axis that one box is not labeled, and then we have 20, and then it's not labeled, and then we have 40. So we see here that every box means that you're going up by $10. So 10, 20, this would be the 30, 40, this would be the $50. All right, so that means that every half a box, every half a box then is worth an extra 5. So this would be 15, this would be 25, this would be 35, half the box would be 45. So each little half a box is worth 5 then if each box is worth 10. Now let's look at how we draw this. We have time worked is 1 hour, so we're looking right at the 1 hour mark, and the pay is $11, so we just go up from 1 hour until you hit about just over 10, and we can make a dot right there because here would be the 11 and there's the 1 hour. Now at 2 hours he makes 22, so we're going to go up to the 20 and then just past it for the 2 hour dots. And then at 3 hours, it works 33, so let's go up to the 30 mark. Here's the 30, but then we want to go a little bit more. 33 is kind of right between 30 and 35, so we should have our dot about right there. And then at 4 hours, Benjamin earns $44, which is pretty close there to the 45 mark. All right, there we go. There are our data points that correspond to our table of values. Now you could draw a line through it, but we also don't have to. So that is the graph to show this linear relation. Let's look at example 2 here. Fanny wants to buy some posters for all of her friends. Complete the table of values based on the graph this time provided. So we're going to go the opposite way. Let's take a look at this graph. We have our y-axis up here and our x-axis over here, and this goes 0, gap 2, gap 4, gap 6. So we know that these are 1, 2, 3, 4, 5, 6. And this goes from 0 at the origin, and it goes skip and then 10, skip and then 20. So these must all be worth 5, 5, 10, 15, 20, 25, 30, 35. And we can even go up 45. Up to there. And this is the cost. Our axis is labeled the cost in dollars, and the x-axis is labeled number of posters. So now that we have these values, let's look at our coordinates. We have for one poster, it looks like the cost is about here. And I would say that's about 8. And oh, look, it gave us that one already. For one poster, it's $8. You might be wondering, what is this N? That's just the number of posters here, so that number can change. So let's look at 2 posters. That looks like that's just over 50, maybe 16. Oh, yeah, and it's already given us here. So let's write in 3 and 4 for 3 posters. Go down. Okay, that was the 3, and it's just under the 25 mark, so I'd say maybe $24. And you don't need to write the dollar symbol here because it's already written up there, so you can just write 24. And then here at 4 posters, you've got it kind of in the middle of 30 and 35. I'd say probably 32. And the reason I say 32 is because I see, so far, I've noticed a little pattern forming. I've noticed that from 8 to 16, you add 8. 16 to 24, you add 8. So these are all multiples of 8. So that's why, even though it could be 33 maybe, that's why I wrote 32, because I'm noticing that all the numbers go up by 8 every time. So the question then is, fill out the table. Woohoo, we did it. Letter B, what would be the cost of 6 posters? Well, this one only goes up to 4, so we can estimate based on this pattern, because we know that they keep going up by 8, right? So 32 plus 8 would be 40 for 5 posters. So at 5 posters, we're going to go across 40, and this goes down to the 5, so we're going to draw our dot right here. And for 6, if we go up by another 8, we get 48. So we go up our 6 and go, here's 45. This one would be 50, so it's going to be right about there for number 6. That would be about 48. So we can see from the graph that we can estimate even further or even down the other way, and we see that 6 posters cost $48. Last but not least, is it reasonable to have points between the ones on the graph? So that means, is it reasonable to have a green point, say, right here? Because it goes in the linear relation. Is that possible to do that? Where would this go? Well, it would be like $13, and it would be at 1.5 posters. 1.5 posters? Can you buy 1.5 posters? No. So no, it is not reasonable, because, I'm just going to say B/C, that means because you can't buy 1.5 posters. All right, there we go. We're going to practice graphing linear relations and turning them back and forth from table of values. More in class next day.